BTEC Applied Science Unit 5 on the thermal physics, and this video is about refrigerators and heat pumps. The last video was about heat engines. This is about refrigerators and heat pumps. Okay, if you think about what a fridge does, it go against the second law of thermodynamics? I mean, we're taking heat energy from somewhere cold, which is inside the fridge, and we're dumping it somewhere warm, which is the kitchen, the room. And of course, it's okay, but something is doing work. That wouldn't happen spontaneously. And it's basically the workings, the electrical gubbins of the fridge. The pump and the condenser, etc., are doing work, and they are taking heat energy from a cold reservoir and they are dumping it to a warm reservoir. So it's the opposite of a heat engine, although technically a fridge is a heat engine, but we won't go there. Now, this was our diagram for a heat engine. We had a high temperature reservoir and the heat energy was flowing from hot to cold and it was doing work. Now, this would be the diagram for a heat pump. We have a cold temperature reservoir at the bottom, and then the heat engine, the device that actually does the business, is taking heat energy from the colder reservoir and it's dumping it into the high temperature sink. Okay, and of course, from the second law of thermodynamics, work is required to do that. So there is a work input there. And this is our heat pump. How does it actually work? How does a fridge work? Well, this is a diagram of actually what goes on inside a fridge. And what we have is a gas is compressed. So starting at the top, we have a compressor which compresses a gas into a liquid. And then the warm liquid goes through some tubes at the back of the fridge and a fan blows air on it and we lose that heat energy. So we are dumping the heat energy to the kitchen or wherever. I mean, interestingly, do you know a fridge will warm up your kitchen because it's dumping heat energy into the kitchen. Then the liquid goes to an evaporator, which is kind of a little nozzle, just like an aerosol nozzle, and it evaporates, it becomes a gas again. When the liquid evaporates, it loses heat energy to its surroundings and it becomes cold. If you spray an aerosol on the back of your hand, it will feel very, very cold. And that's the latent heat of evaporation. Sorry, latent heat of vaporization, it's called. We'll talk about latent heat in the next video. And then this cold gas goes inside the fridge and the cold gas absorbs energy, heat energy from the fridge, and it keeps your peas nice and frozen, whatever, absorbs heat energy, then it goes to the compressor, etc., goes round in a circle. And that is how a fridge actually works. That's the mechanics of the fridge. These things are very, very similar to a fridge, and they call them heat pumps. And it's a way, they're getting very trendy now when you're building houses. If you watch Grand Designs, we built our house in the countryside. It's very eco-friendly. We get do our heating using a heat pump. And basically what it does is it's taking heat energy from the ground and it's pumping it into the house. Even though the ground is a colder temperature than inside the house, it's taking heat energy from the ground. If it's a ground source, it could be an air source one or a ground source one. And it works in a very, very similar way to a fridge. The actual mechanical bit, the heat pump bit, will involve a gas evaporating and being condensed. There will be a condenser in there. Okay, so they take energy from a cooler reservoir, which is either the air or the ground, and then the sink is inside the house. They can actually be used for air conditioning as well. They can work in reverse and be used to keep the house cool. Now, heat pumps are becoming more and more popular because they are very efficient. Of course, you need a very, very large back garden if you're going to use it to take heat energy from the ground. But they're very efficient. There's something you need to know. It's called the coefficient of performance, the COP of a heat pump. And that tells us how good they are, how efficient they are. And the COP is the power that the heat pump puts into the house, the power from the heat pump, divided by the power used by the compressor. And typically you're talking about somewhere between 2 and 3, 2.5 and 2.8 are typical values. If you use it for cooling, a typical value is about 2. Okay, so if you imagine you're giving 1 kilowatt to a compressor and the house is getting 2.5, 2.8 kilowatts of heat, that's pretty good going. Okay, they are good. Here's an example of a question very similar to one I saw in an exam paper. A heat pump used for heating a house has a COP of 2.5. If the compressor uses 0.9 kilowatts of power, calculate the heating power delivered to the house. And there we go. So the power delivered is the COP times the power of the compressor. So that is 2.25 kilowatts.